Hello students, welcome to Database Management Systems. I'm Dr. Munir Omar. Today in lecture number 46, we will go through the entire procedure of normalization by taking an example case. These are the contents for our today's lecture. First, we will look into the normalization. We have already studied about normalization. We will also check one additional thing in it, that is the well-structured relation. So we will also study about that. After that, the database normal forms. We will redefine these normal forms as we need these definitions for our upcoming example table. So once we take an example table, after that we will go through some steps to normalize that table. We will normalize that table up to FACULTY402-CS222-K. So normalization is a formal process of decomposing relations with anomalies to produce smaller, well-structured and stable relation. Actually, if there are some anomalies in the database tables, then that would be most probably due to the redundancy. So to eliminate the redundancy in database tables, we decompose those tables into smaller and well-structured tables. Primarily a tool to validate and improve a logical design so that it satisfies certain constraints that avoid unnecessary duplication of data. Once a database table is normalized, then it would not be prone to any unnecessary duplication of data. Actually, in most of the cases, we will put some additional constraints, or that table will be constructed in such a way that that table would not allow any sort of duplication of data that might cause any anomaly in the database. By well-structured relations, we mean that a relation that contains minimal data redundancy. The redundancy level is at the least, and allow users to insert, delete, and update rows without causing any data inconsistencies. If there is less redundancy, there is less duplication of data in the database tables, then there would be definitely less chances of insert, delete, or update anomalies, and the user would be able to keep their data in the database tables in consistent form. These are the normal forms which we need for the normalization of a table in the coming slides. So we have already studied about these normal forms. In the first normal form, we look for the repeating groups or multi-value attributes. We say that if there exist scalar values under each column and we are able to specify keys, then that table is in first normal form. In second normal form, we look for partial dependencies. If there is no partial dependency in the table, then that table would be in second normal form. In third normal form, we look for transitive dependencies. If there is no transitive dependency among the attributes, then that table would be in third normal form. In 3.5 or Dcnf normal form, we say that all the candidate keys are determinants keys. In fourth normal form, we look for multi-value dependencies. We check for many to one relationships among the attributes. In fifth normal form, we try to decompose the tables up to the maximum possible level, where we don't lose any sort of data. And in the last normal form, that is Dcnf, domain key normal form, we enforce the domain constraints for ensuring the consistency of data in the database tables. So this is the example table, and we will normalize this table. If we look into this table, it has some attributes: name, project, task, office, floor, and phone. There are 6 attributes in this table. There is no primary key or any candidate key, and if you look into this table, it is in raw form. Now the first question is whether this table is in first normal form or not. This is first. If this table is in first normal form, then we must ensure that all the attributes or columns are storing scalar values. There is no multi-value attributes in this table. So if we look into this table, we have some multi-values here under project, here again, and also here we have some multi-value attributes. So due to these multi-values under attributes, we can say that this table is not in first normal form. So we must convert this table into first normal form by eliminating these values, these multiple values under columns. Now what we did, for each additional value we gave one additional row. For each value, here we have one row. If we look into this table with Ali, here we have 2 values, and here we have 2 values. All are in one row. And here for Ali, we created 3 more rows to accommodate those additional or multi values under columns. So for 100 we first took T1, and then again for 100 we took T2. Here T1 for 100 and T2 for 100. Similarly for 200, why? We took T1 and then took T2. And for Ahmed, we have 3 values under project, so we need 3 separate rows for this single row. So here we created 2 additional rows to accommodate these values. So here these values are separated in new rows. Now this table contains atomic values under each column, and we can say that this table can be considered as in first normal form. But there is one additional thing, that we must specify the primary key for this table. We assume that the names are unique. These are the names of employees, so these are unique, these are not repeating. In most of the cases we use IDs for names, but to avoid any complexity with the name, I'm not using this ID. I assume that the name attribute is taking unique values. So we can say that this name could be a primary key. But if we use this name as a primary key, what will happen? We will get error. We will violate the primary key rule because these names are repeating. So what we do, we combine this name with project, and again we check whether is there any violation or not. Now here Ali 100 and again Ali 100. So again there is repetition. So we are now combining this task 2 with these 2 attributes to make a primary key. Now if we combine this task with these 2 attributes, then we will have a composite of 3 attributes. And now if we look into the values, then there would be no repetition. Ali 100 T1, Ali 100 T2, Ali 200 T1, and Ali 200Y T2. So there is no repetition if we combine these three attributes for primary key. So all the combinations would be unique. So we can specify the primary key as the composite of name, project, and task. So this would be our primary key. Now this table is in first normal form. Imply, name, project, task. These three attributes are composite, and they are forming a primary key. And after that, we have three more attributes. Now we are moving toward the second normal form. Whether this table is in second normal form or not, here we have a composite key, name, project, and task. So we must check the condition that are all the non-key attributes fully dependent on all of the key, means that all these three attributes are whether fully dependent on this composite key or not. So this is the condition. If this condition is satisfied, then it would be in second normal form. But if we look into this table, then it is obvious that the office and phone can be determined by knowing the employee name only. If you know the employee name, if I know Ali, then I must also know, or I can determine his office number, and I can also determine his phone number. So I can say that these two, the office and phone, these are partially dependent on this composite key. These are also determinant of name, or we can say that office is dependent on name, phone is also dependent on name. So there exists partial dependency in this table. So we can say that name can determine office in the same way floor and phone. So these are determinant, or these are dependent on name. Now what we need a separate table to remove this partial dependency in the table. So what will we do? We will take these three attributes as a single table and these attributes with name. So here we have one more table, and the first one is also reduced. So now here we have two tables. This table is decomposed into two smaller tables. The first table contains that composite key, and the second table contains those attributes which were partially dependent on that composite key. Those attributes were dependent on name. So we used name with these three attributes. So now this table, or both these tables, are in second normal form because there is no partial dependency in these two tables. So here we have now two tables made from this one table. Note one thing, that after the decomposition, these duplicated values will be deleted automatically. If you look into the first entry, it is exactly similar to the second entry, so no need of these additional entries. These will be deleted automatically. So the table would be like in this form without any repeated values. Now, third normal form. We must check whether these two tables are in third normal form. For third normal form, we must check the transitive dependencies among the attributes. Now, if we look into the first table, this is a composite, so there is no chance of any transitive dependency. And in case of a second table, we must check whether the attributes are having any transitive dependency among them. Now, if we look into this table, the name is determining office, and name is also determining, sorry, the office is determining the phone. So if A determines B and B determines C, then A must also determine C. So this is the case of transitive dependency. Name determines office, office determines phone, so name must also determine phone. So this is transitive dependency. So we must remove such type of transitive dependency. Now, if you look into this table, the transitive dependency is due to the phone number. So we must eliminate this phone number from this table. We must create a separate table for this phone and connect with the office and keep this table as it is without phone. So we are going to decompose this table into two more tables. So here we have name, floor, and name, office, and floor, and this phone is separated from previous table. And now to connect both the tables, we are using office here with this phone. So these two can be connected with the help of office. So now these three tables are in third normal form. There is no transitive dependency among the attributes in any table. Now here we have three tables created from two tables in previous case. Next we have Dcnf. We must check whether the candidate keys are determinant. Now if you look into the first table, this is a composite, so there is no additional attribute which can be checked for determination. So we can say that this one satisfies the condition for BCNF. Now if you look into the second table, this one is candidate key. We made this name as primary key. It is also a candidate key. So these two attributes are dependent on this name. So this candidate key is determinant, so it's okay. Here we have only two attributes. The name is fully dependent on name, but the phone is fully dependent on name, so the candidate key name is also determinant. So these three tables are also in BCNF, Bayes code normal form. So we are not changing these three tables. Next is fourth normal form. For fourth normal form, we must check the multi-valued dependencies in these three tables. Now if we look into this first table from right, the name and phone both are holding unique values, so there is no chance of multi-valued dependencies. Here again we have no chance of multi-valued dependencies, but in this table we may have multi-valued dependencies. Now if you look into this Ali, it is with the 100 T1, then 100 again, and T2. So for Ali we have multiple values here under project, and also we have multiple values for tasks. So there are multi-valued dependencies, so we must separate these attributes to form some new tables. We created two more tables from one table, and if you look into these two tables, now here we separated this task with name and project with name. So here we have now two more tables, so we satisfied this multi-valued dependency condition for fourth normal form. So here we have now four tables instead of three. In previous case we had three tables. Now these tables are in fourth normal form. we can also decompose these tables for fifth normal form, but if we look into these tables, there is only minor chance of further decomposition. We cannot decompose this table because it has only two attributes. Same is the case with this one and also this one. These cannot be further decomposed, but for fifth normal form we can decompose this table. We can create two more tables. In one table we will have name, office, and in second table we will have name, floor, or office, floor, depending on the dependencies. If office is sufficiently determining the floor, or floor is sufficiently determining the office, then we can create a new table for these two attributes. So this was all about normalization, and we started with a simple table in raw form. It had multiple values under attributes. Then we separated these values in different rows. We created multiple rows, and also we specified the primary key, which is composite of three attributes, and we formed this table into first normal form. For second normal form, we removed the transitive dependencies among these attributes, and we created or we decomposed this table into two more tables. And in third normal form, we checked for transitive dependency, which existed in this table. Name was determining office and office was determining phone. So we separated this thing and we decomposed this table into two more tables. In Dcnf, we checked for the candidate keys, whether these are determinate or not. These were already determined, so we did not make any change in these tables because these were already in Dcnf. In fourth normal form, we checked for multi-value dependencies. Here existed some multiple values under attributes, so we separated these attributes into two more tables, and we decomposed this table into two tables having name project and name task. So ultimately we got four tables. There is a space of one another table. If we want it in fifth normal form, then we can further decompose this table into two attributes and then again two attributes. So this was all about normalization. During the normalization process, always start with first normal form. First we must check the condition for multi-value attributes. Start with first normal form. After that, second, third, we must follow the sequence and also check the conditions for each normal form. For each normal form, check the dependencies and keys. This is very essential. Whenever we create a new table, we must specify keys. So here in these tables, we also specified the keys for the attributes. Thanks.